Welcome to the deep dive. Today we're jumping straight into the world of VMware Cloud Foundation VCF.
That's right.
It's powerful, no doubt, but let's be honest, it can sometimes be tricky.
Definitely has its moments.
So think of this as your shortcut, your inside track to really getting a handle on VCF troubleshooting and best practices.
Yeah, we're looking at common problems.
Exactly. We're not just going to list problems. We want you to understand why things break and, crucially, how to fix them.
Practical stuff.
Practical, real-world knowledge. We're pulling insights from scenarios you might face during deployments, upgrades, day-to-day ops.
Stuff that actually happens.
Right. So whether you're maybe prepping for a cert or just trying to keep your VCF stack happy, this is for you.
Absolutely. And these scenarios, they aren't just academic. They really do represent the kind of things that cause headaches in real VCF environments.
Like actual support ticket.
Pretty much. Critical config details, common mistakes. By digging into these, you get a much better feel. Exactly. You start to build that intuition for what breaks, why, and, the quickest way to get things running again.
Okay, let's unpack this then. Let's start right at the beginning. Day one. You've got your shiny new VCF deployment.
The optimistic phase.
Yeah, exactly. And then, bam, it hits a snag. Right at the network validation stage.
Uh-oh.
That error. VLAN trunking issue on the management network. What's the likely culprit here? Why does this pop up so often early on?
Okay, yeah, that's a classic. VCF networking absolutely depends on VLANs working correctly.
Fundamentally.
So that VLAN trunking error, it's basically shouting that your VLAN tags aren't getting through the physical network properly.
Okay.
And 9 times out of 10, maybe even more, the reason is the physical switch ports your ESC hosts connect to. They're probably set up as access ports.
Ah, instead of trunk ports.
Exactly. Access ports strip the VLAN tags, right?
Yeah.
They expect just one VLAN. But VCF needs multiple VLANs on those links. Management, vNANN, vMotion, workload traffic.
All sharing the same pipe.
All sharing the same pipe. So those ports have to be configured as trunk ports to let all those tagged VLANs pass through. If they're not, VCF can't set up its networks and deployment just stops.
It's a hard requirement.
It's a hard requirement. A foundational network piece you absolutely have to get right.
So it really boils down to that physical layer setup. What does this tell us, though, about the mindset you need for VCF networking from the start?
That's a great point. It shows VCF isn't just software you install. It's a whole software-defined data center, and it leans heavily on the physical network being configured correctly for it.
It's not just running on the network.
Right. The mistake is thinking of VCF hosts, like old-school standalone ESXi hosts that might only need one VLAN. VCF, with workload domains, vSANs, NSX, it demands trunking from the get-go.
So plan for it.
Plan for it. Design your network for VCF. Don't just assume your existing network will work without changes, overlooking that early on. It just leads to headaches later.
Makes total sense. Get that foundation solid. Okay, so let's say you got past deployment, VCF is running, now you want to expand.
Adding capacity.
Right. You're adding a new ESXi host to a workload domain cluster. But the commissioning step fails? Error message. Host not found.
Another common one?
What's a frequent, maybe easily missed reason for the SCDC manager not being able to find that new host?
This one's interesting because it shows how a simple connection issue can stop a complex process cold.
Right.
When SDDC manager, which remember is brain of VCF, says host not found, it almost always means it can't make an SSH connection to that new host.
Ah, SSH access.
SSH access is mandatory for commissioning. So if there's a firewall blocking port 22 between SDDC manager and the new host,
where the service isn't running on the host.
Exactly. Or SSH isn't running, or it's misconfigured on the ESSCO host itself, or some other network issue is preventing that secure shell connection, then SCDC manager just can't talk to the host. It can't integrate it.
So again, basic connectivity, but absolute critical. Whether it's VLANs for deployment or SSH for adding hosts, these aren't minor details.
They're showstoppers. Precision is key.
Okay, let's shift gears. We've got VCF running. How do we keep it healthy and secure, especially during things like upgrades or certificate renewals?
Yeah, the ongoing care and feeding.
Let's start with upgrades. You're moving from, say, VCF 5.x to 6.0, whatever the next big jump is.
Right.
And it fails. You get a pre-check error, disk space availability. Which component do you check first, and why?
Okay, this immediately points to the orchestrator, the SDDC manager.
The brain again.
The brain again. VCF upgrades rely heavily on the SDDC manager appliance. It's not just kicking off the upgrade. It's storing logs. It's downloading the upgrade bundles. It's holding temporary files.
Needs working space.
It needs working space. If its own disk space is full or nearly full, the upgrade process just can't proceed. So that disk space availability error. First place to look every single time is the SDDC manager's file system utilization.
Got it. Check the conductor's podium space.
Exactly. No room for the music, no concert.
Makes sense. But thinking about SDDC Manager, beyond just disk space for upgrades, are there other ways it can become a bottleneck that people should watch out for proactively?
Oh, absolutely. Disk space is common, but you should also monitor its CPU and memory usage, especially during big tasks like upgrades or domain creation.
Resource contention.
Right. Also, network latency between SDDC Manager and the components it manages, vCenter, NSX, hosts, that can slow things down or cause timeouts.
Oh, okay.
And of course, the health of its internal database and making sure you have good backups. It is the central control plane. Anything impacting it impacts the whole environment.
So proactive monitoring of the SDDC Manager itself is key.
Paramount, yeah.
Okay, security time. Certificates. Always fun.
Oh, yeah.
Fun. You've just replaced the SSL certs across your VCF fleet, imported the new ones, feeling pretty good.
Check that box.
Check that box.
Yeah.
But then you notice some services are still using the old certificates. What's going on there? Why the discrepancy?
This one catches so many people. It's a really common oversight.
Okay.
Even after you successfully import those new certificates into the system, many VCF and vSphere services, they won't actually load the new certs until they're restarted.
They cache the old ones.
They cache the old ones in memory. So if you don't restart the relevant services after replacing the certs.
Like vCenter services, NSX manager services?
Exactly. Potentially others, depending on what you replaced.
They'll
just keep using the old cache certificates. That causes the discrepancy, and it can lead to trust errors or weird communication problems down the line.
So it's the classic, did you restart the service?
Pretty much. A simple step, but so easy to forget in the heat of the moment.
Good reminder. Okay, staying on security. Passwords. They expire. It happens.
It does.
So a password for a key component, maybe vCenter server, expires. What's the right way to update that password within the VCF world to keep everything synced up and avoid authentication failures later?
Right, and this really highlights VCF's integrated nature. You don't just go change the password in vCenter. Well, you could, but that's not the VCF way, and asking for trouble. VCF has its own built-in password management feature right inside the SDDC Manager.
Okay, centralized again.
Centralized. That feature is designed to synchronize passwords across all the integrated components, vCenter, NSX, ESXi hosts it manages, potentially others.
So you update it there.
You update it there in the SDDC Manager's password management or credentials section. That ensures the change is pushed out consistently everywhere VCF expects it. It keeps the inventory accurate and prevents those auth issues you get if one component's password drifts from what SDDC Manager thinks it should be.
Maintaining that single source of truth for credentials.
Exactly. Don't break the chain. Use the VCF tools.
So yeah, SDDC Manager really is the central nervous system for all these critical admin tasks. Upgrades, credentials, deviate at your peril.
Pretty much sums it up.
Okay, let's pivot to operational issues. Maybe performance problems, migration challenges within your workload domains.
Day-to-day firefights.
Sometimes, yeah. Let's say you've got a workload domain and performance is just tanking. You dig in, look at vSAN health, and you see several ESXi hosts have a lot of vSAN component objects showing up as absent. What's the most direct cause of that situation?
Okay, seeing absent components is always a worry in VSAN. But when you see it on multiple hosts simultaneously...
Yeah, not just one host acting up.
Right. That almost always points straight to network connectivity problems between the ESXi hosts themselves.
The VSAN network specifically.
Yes, the VSAN network. VSAN absolutely relies on constant, reliable, low-latency communication between all the hosts in the cluster if they can't talk to each other effectively.
They can't maintain quorum or resync data.
Exactly. VSAN can't do its resyncs. It can't rebuild components if a drive fails or a host is down. It can't maintain quorum properly. Components get marked absent because the cluster state is inconsistent. And the direct result is often severe performance degradation.
So check the host-to-host VSAN network first. Switches, NICs, cabling.
Absolutely. Before you start blaming disks or controllers, make sure the network underpinning VSAN is solid. It's critical.
Got it. Okay, different scenario. External access. Users can't reach a web server running in a VCF workload domain.
Common complaint.
But here's the kicker. If you ping that web server VM from another VM on the same subnet, it works fine.
Oh, okay.
But try pinging from outside, from an external network. Fails completely. What's the first troubleshooting step there?
Right. This nicely isolates the problem. Internal east-west traffic on that segment is okay. The VM is up. Its network stack is fine.
So the issue is getting in from the outside.
Exactly. It's a north-south traffic problem, and in VCF, that means looking at NSXT. The most likely first step is to check the NSX gateway, usually a Tier 1, maybe connected to a Tier 0.
The gateway serving that web server's logical segment?
Precisely. You need to verify that that gateway has a valid route to the external network, and just as importantly, that the external network knows how to route back to the subnet advertised by that gateway.
So routing tables on the NSX edge gateway.
Check the routing, check route redistribution, check firewall rules on the gateway. Something is stopping traffic at that VCF network edge. The path from the outside world to your internal segment is broken somewhere on that gateway layer.
Makes sense. Narrowing it down to the edge. Okay, how about migrations? You're using HCX.
Hybrid cloud extension, good stuff.
To migrate workloads from an older vSphere environment into your nice new VCF workload domain, but it keeps failing.
Right.
The error message mentions host-side network connectivity. What's the absolute first thing you should check when you see that?
HCX connectivity errors. When you're going between different environments, especially a legacy one and VCF.
Yeah.
The first thing, check the firewall rules. Seriously.
The network firewall between the source and destination?
Yep. Physical firewalls could be NSX distributed firewall rules, maybe security groups in either environment. HCX needs a specific set of ports open to build its tunnels and manage the migration.
For the interconnect appliances, network extension, etc.
All of that. If those required ports are blocked anywhere along the path, the migration will fail with connectivity errors like that. I can't tell you how many times people chase complex HCX config issues when it was just a missing firewall rule.
Start simple, check the ports.
Always. Check the HCX documentation for the required ports. Verify end-to-end. It saves so much time.
Firewall rules, the bane of our existence, but always check them first. Okay, one more in this section. Modern apps.
Kubernetes time.
Kubernetes time. You've enabled a workload domain for VMware Supervisor running Kanzu.
Okay.
A developer calls up. They're running a kubectl command, and it's failing. But, and this is key, it only fails for one specific namespace. It works fine against other namespaces in the same supervisor cluster.
Okay, that's a huge clue.
Right, so what's the first thing to troubleshoot?
The fact that it works for some namespaces but not others tells you it's almost certainly not a general cluster problem, not an API server issue, not a fundamental connectivity problem.
It's specific to that one namespace.
Exactly. Which points directly to permissions. Role-based access control, RBAC.
Kubernetes RBAC.
Yep. The user or service account running that kubectl command likely doesn't have the necessary permissions, the right role, and role binding assigned within that specific namespace.
Even if they have permissions elsewhere.
Even if they have permissions elsewhere, or even cluster-level permissions. Kubernetes RBAC can be very granular. So the first step is kubectl auth CANI namespace, the failing namespace, or checking the role bindings applied to that user group in that specific namespace.
Got it. Check permissions within the failing context. Makes perfect sense for Kubernetes.
It's usually where you find the issue in a scenario like that.
Super helpful. Okay, finally, let's talk smart administration. VCF is complex. Efficiency matters, especially when things go wrong and you need info fast.
Absolutely. Time is critical.
So, scenario. You're troubleshooting a tricky recurring issue. VMware support asks you to collect logs from the entire VCF fleet.
Oof, that sounds painful manually.
Right. SSing into every ESXi host, vCenter, NSX manager, SDDC manager. That could take ages. What's the efficient way?
This is where VCF's integrated tooling really shines. You absolutely do not want to do that manually.
Please tell me there's a button.
There's basically a button. Inside the SDDC manager, there's a feature called Log Assist.
Log Assist.
That's its job.
Yeah.
It automates gathering the log bundles from all the different VCF components, ESXi, vCenter, NSX, the SDDC manager itself, across the entire deployment, or specific domains if you prefer.
Fantastic.
And often, it can even handle uploading that consolidated log bundle directly and securely to a VMware support request ticket.
Wow, okay. That's a huge time saver.
Massive. It turns a potentially hours-long, error-prone manual task into a much quicker automated process.
Yeah.
It's built for exactly this kind of need.
That really highlights the value of that integrated management plane. Using the built-in tools is key.
Definitely. Work smarter, not harder, especially with logs.
Well, thank you so much for joining us on this deep dive into VMware Cloud Foundation troubleshooting and best practices. We hope you found it valuable.
Hope it helps out there.
Absolutely. We encourage you to keep exploring, keep learning. Until next time, keep digging deep.